go through an example which shows you some of the issues that you get with asynchronous processing. We're going to have some tips for how to actually handle those things before we eventually wrap up. So what even is async? And why are there zombies on the screen? Generally, I'd say asynchronous processes are where there are two processes where their execution overlaps in time. And it could be that you only have a single processor that these processes are running on and they're having to share time within that. And if you're old like me, you may remember one of the selling points of Windows 95 was that it had preemptive multitasking. And it's good to have these notions in your mind of there are two different ways of the sharing. Pre-Windows 95, whatever process was running would only give way to another process when the code allowed it to. Whereas Windows 95 allowed the operating system to say, no, you're done, I'm taking you off and switching the next one in. And so whenever you're looking at an asynchronous system, it's good to think to yourself, what kind of asynchronous system is this? And then beyond having one processor, it could be that you have multiple processors, multiple cores that you're running things on, and then things are truly running in parallel, and that's kind of what we tend to see in Salesforce. So the relationship between events and asynchronous is they're not exactly the same thing, but they're often related to each other. When people talk about event-driven systems in Salesforce, they tend to also mean asynchronous. And if you're going to build something with asynchronous processing in it, events are a good way to coordinate that. So I'm kind of going to say they're the same thing for this. Why the zombies? It comes from a Unix definition of, in Unix, if a process is running asynchronously, it has an entry in the process table. And it can sometimes happen that the process is finished, but it still has an entry in the table. And in that case, they call it a zombie process. The other thing is race conditions. If you ever interview at Nebula Consulting, I'll ask you about race conditions. And race conditions are when the two processes are trying to access the same resource, and the job of the programmer is to make sure that whichever way that race turns out, the system still ends up working properly in some sense. And I spent quite a long time chasing down a race condition on a zombie process and then make that image to relax afterwards. So I'll just like show you. So where do we see asynchronous processing within Salesforce? We see it in batch, we see it in schedule, we see it in queuable. Future methods exist, but don't use them, just use queuable. Flow has asynchronous paths. Web components are a real place where it comes up. Every time you have a communication between a web component and the server, that's an asynchronous call. You could send a whole load of requests to the server and there's no guarantee they come back in the same order. Platform events are one of the things that enable it. Multiple users, if you and I both save the same record, then there's a race between us to see whose save gets there. And communications with external systems also come up there. So we're going to take a step back from Salesforce and talk about the async properties of the database. So this was a set of properties that some people came up with as being a way that if your database satisfies these things, it's easier to work with. So we'll go through them in order, which would have been much more exciting if it was animated and you wouldn't have been able to read them all. So the database actions either fully succeed or fully fail, and they never leave any half-done stuff. Database is consistent if all the data satisfies all the validation rules and all the trigger enforced stuff is true. So if you have a trigger that says whenever A happens, the trigger is going to make B happen, and your database is consistent, wherever you have an A, you're going to have a B. Isolation is all about the parallel processing. So transactions are isolated if, when they run in parallel, it's the same as if they run in sequence. So if you imagine two parallel processes, one that's adding £10 to something and the other one's taking away 5, the end result, if isolation works properly, is you end up plus 5. And if you're not isolated properly, you could end up with some wacky other result. And they should also be durable. So once something's committed, it should stay committed. Now, that's databases in general. What really is Salesforce other than a great big database with some cartoon characters stuck on it? So we could ask ourselves, is Salesforce satisfying ACID? Atomic, we're pretty familiar with. Yes, transactions do fully go or not go. You can break it with code if you want to, but by default it's atomic. Is it consistent? Not really fully. There are ways that triggers don't run and validations don't run. Cascading deletes is one,
Implementation is
and lead
quick.
conversion is another. There's a whole page with a list of them, so we can't fully rely on that, but it's mostly there. Are the transactions isolated? They're isolated in the sense that the Salesforce docs say they are, but they're not isolated in the sense of the async thing. If you imagine you had two parallel things with my example of adding 10 and taking away 5, the way Salesforce does it, those two transactions don't see each other, but they both start with the same total. So if you add £100 and you add on 10 and take away 5, one of them is going to write 90. One of them is going to write 110, the other one's going to write 95, and whoever finishes last is going to be the end result. So actually, in that sense, Salesforce would do the wrong thing unless you add to it. But I will give them durable. In my experience, it's been pretty durable. So,
Salesforce.
Async and the inverse Yoda. So Yoda is a big fan of atomic transactions. Do or do not, there is no try. And there's a difference between transactions and business operations. In Yoda's world, there is a business operation is a transaction, and the whole business thing happens or it doesn't happen, and that's it. But if we decide to move into the async world, then we've broken this up, that our business operation is now multiple transactions. And we end up with this inverse Yoda of, we tried to do the thing, maybe it worked, maybe it didn't, maybe some of it's done. And it's a lot more complicated. So the database is still working in that ACID sort of model, but the business operations are not. And we need to be intentional if we choose that we're going to do this.
Danger.
So my laptop's gone super slow. So let's go to an example scenario, and let's consider every time an account's inserted, we want to do two things. We want to set the account number to a UUID, which is just a globally unique string, and we want to create a log record. Just those two things. And we could viably do this with a synchronous Apex trigger, we could do it with synchronous flow, we could have some scheduled thing going around and picking up ones that are not done, or we could do it with a sort of near real-time asynchronous. And depending on your system, any of those things could work for you. So bearing that example in mind, I'm going to talk a little bit about what makes code easy or hard to reason about, and I want to be quite specific about that. So when we're reasoning about code, it's much easier to reason about a linear chain of events, and keeping business operations within a single transaction gives you that linear chain of events. So if I insert the account, I set the UUID, I insert the log, everything's done. Or if at any point it fails, it all fails. And that's quite easy to think about. And the other model, which is not going to work because I don't have animations, unfortunately. It's just not going to. So the other model is that you end up with a blank screen. I'll draw you a picture in a minute. Is the branching time alternative, where if we decided to do those things asynchronously, then we insert the account and we're not sure whether the UUID or the log comes next. I'm going to try and just delete stuff from my presentation so you can see what's going on. Never mind animations. So manual animation. So once we're in this world, at each step of the process, you could succeed or fail. So the solid lines are successes, the dots are fails, and we don't know whether we're going to do the UUID first or the log first. We end up with this array of different possibilities of partial successes in different ways, in different orders. And I would say this is a lot harder to think about than the previous one. I imagine you would agree. So one other thing about reasoning about code is it's good to minimize the amount of state that you have in your system. That makes it much easier to think about. If we think about how programming languages evolved from the old times of C, we started to put stuff into functions to move the state smaller, and then we put them into objects to make the state smaller. And at any time, if we can have less state around, it's easier for us to think about. And Psychologists think we can hold about 4 things in our working memory and think about them at any one time. So you could do a bit more than that if you're an expert in a domain, like chess players can hold more chess moves, and we can probably hold more variables when we're thinking about it. But still, we're pretty limited, so we don't want to tax that too much. The algorithm. And a Snorlax, which is there for a reason. So the algorithm here is one that I heard about from a blog post by Kevin Henney, and I saw this algorithm and I thought, this is amazing, this is useless, I have to share it with people. So I shared it with everyone at work, and then I tried to find a way to shoehorn it into a presentation. But actually, I think it's quite useful here too. So the algorithm is called sleep sort, and it's a way to sort a list of numbers. And so the top bullet point there is the algorithm. For each value in the array that you have, sleep for the length of time proportional to that value, and then add it to the new array, and your new array will be the sorted list. So if we take a delay of 200 milliseconds and we get that list of 3159, simultaneously we set off a whole bunch of timers for 600, 200, 1000 and 1800 milliseconds, and then as each of those finish, chances of this working seem slim, but let's give it a go. Yeah, there you go, it's running. So given that random array, it's printing out the results incrementally as it goes along, and it sorts it. Amazing. I bet you're all going to rush your way and implement that. It's actually quite fun. We did it as a coding exercise. So here's the code that I used for that. And in JavaScript, there are 3 arrays involved. There's the input array of random stuff. There's an array of promises, because we're going to wrangle the asynchronous things, and then there's the result. So what we do is we loop through the inputs, and for each of the inputs, we're going to add to the array of promises a promise that we're going to sleep for a bit and then add to the array. And once you've done that, all you need to do is await those promises resolving, and then you're done. So you ask yourself what's inside sleep and add to array. As I say, what we do is we're going to sleep using set timeout for the length of the value multiplied by whatever our thing is, so 200 milliseconds. And then the actual thing you do after the timeout is you push the results onto the array. That's it. And what's interesting about that is that there's no manipulation of variables going on to do the sorting. We're not doing any comparisons. We're not doing any swaps, any of the things that you normally be doing. And what magic is allowing us to do that is that time itself has become the variable. And going back to what I was saying about state and minimizing state, suddenly we've got this extra continuous variable that's not written anywhere in the code and is very hard to think about. And that is the magic behind sleep sort, but that's also some of the pain that you have when you try and work with asynchronous systems. And if you have a thing where you have branching in it, it is harder to reason about. And humans are famously bad at multitasking. I realized this when I was driving around Aylesbury listening to Miles Davis, and I found that I cannot drive around roundabouts and listen to jazz at the same time. I had to switch on. And so putting myself in a position where I have to deal with asynchronous stuff is something I would prefer to avoid or minimize. So why would we even want to do this? It's hard, why would we bother? One reason is speed. If you have multiple processors available to you and you can break out your work into chunks and have them happen in parallel, you can get the results faster, which is great. Responsiveness is another good reason. That's why web components work the way they do. If you have a long-running process, then the user presses the button, you send that away to happen, and then you make the UI responsive again, and you maybe grey out the button so they can't restart it. Salesforce limits is another good reason. So you can't really paper over bad design by making everything asynchronous. And if you've coded yourself into a corner with terrible synchronous triggers, don't try and write asynchronous triggers because it's even worse. But there are things which are just essentially expensive. If you've got lots of data to process, then sometimes you have to do this. And Salesforce forces you with callouts. And also, it's useful for decoupling things. So atomic transactions are great, but it means that every single thing that happens in that synchronous trigger has to succeed or the whole thing gets rolled back. So if we've got a sales process where every time an opportunity gets closed won, we need to create a shipping order, notify the warehouse, whatever else, and then Bob decides he also wants to fire a confetti cannon on his desk, and for some reason the confetti cannon goes wrong. That breaks the warehouse, the shipping, all of it, if it's all tied together in a synchronous transaction. So sometimes it's good to use async to break things up like that. So on the right-hand side, we've got some statements from the Salesforce Architects website about async. And I think the top one is bonkers. So they say use async operations for all after context trigger actions. That's in there. You look like you don't believe me, but sorry, it's well architected. And then underneath, when they're talking about event-driven architectures, they say before implementing an event-driven architecture, stop to consider if you truly need one in the first place, which is very much more where I am. I think the Architects website is amazing and you should read all of it. But I think, I very much don't agree with the first point about what happens if, about making everything async all the time. I think is risky. So what can we actually do to deal with this complexity? Make the implicit stuff explicit. It's much more of a reveal when the pyro comes on at the end, I'm afraid. So before you start an async operation, you should store in the database somewhere that that's what you're planning to do. And that way it's going to help you to debug it later. Which often means having a consistent approach to logging across your whole system, which is really something you should do anyway. And it may lead you to having to store stuff off platform, because if there's enough of a volume of events, you might not be able to fit it in Salesforce. But what you really don't want to be is in a situation where you haven't done this, something's going wrong in production, and your first deployment is to add some instrumentation that you should have added before. Otherwise, your pants won't show and you're looking bad. So, tip number 2. I wonder how much of this presentation is going to be waiting for them. Yeah. So, I make operations idempotent. If you haven't come across the word idempotent, it's great to make you look clever, but it's actually got quite a simple meaning and it's a powerful idea that every time you do the operation, you do it once and all the subsequent calls to it have the same result as the first one. So no matter how many times he hits that guy with the chair, the result is the same as it was the first time. I'm going to stop those guys from animating because they're quite distracting. So some operations really lend themselves to that idea of idempotency, that something like an upsert, the first time you do an upsert, the thing is created, and if you call upsert again, the thing's still there. Some APIs offer idempotency keys, which are really useful. So some payment APIs, you can pass it the ID of what you're taking the money for, and if you ask for that same money twice because you weren't able to store the first collection of the money, the payment thing will say, no, you've already done that. And those kinds of things are really useful to lean on. So they're really great for situations where you might want to automatically retry an error which comes and goes. My third tip for async is write the hard parts once. So if I have to write really difficult code, I put on some strong coffee and get right into it. And that's not something that I could do all the time. I don't want to have to be on top of my game and high on caffeine every single day. It's not sustainable. So what I would recommend with async code is make the hard parts once and then reuse that as much as you can, because it's difficult to test. And if you get that right, you can make your day-to-day use of asynchronous stuff a bit more commodity. I don't have to worry about the hard parts every day. And if you can make an unlocked package with this and you can use that as your way. Or you can just document whatever your standards are, and you pull out the document and you follow that every time, and it's going to go fairly right as long as you follow your docs. Tip number 4, belts and braces. So every time you fire something off asynchronously, you need a second method to check that it's actually worked. And Apex has these convenient things. If it has transaction finalizer, it's for queuable, and it has batch Apex error events. So if queuables or batch blow up, even with a limit exception, the transaction finalizers and the batch Apex error event allow us to find out that that happened, record it, retry it, whatever the right actions are. But it's also worth having a scheduled process to go one step beyond belt and braces and make sure you're even wearing trousers in the first place. So if you want to do like a near real-time integration, it often makes sense to have a scheduled job that goes and picks up anything that got missed for any reason along the way. And if you did a previous tip and you made your operations idempotent, you can use these scheduled processes to retry stuff that failed for locking errors or for whatever else. Okay. There we go. Last of the tips. Treat it like science. So with the normal synchronous code, you know what you're doing. You're kind of logically moving through stuff. You can predict what's going to happen. But actually, by the time you get to asynchronous systems, it's more of a thing that you poke at and you observe. So you need to think, what is going to convince me that this asynchronous system that I've built is actually working properly? What tests am I going to be able to put into production? What reports can I write that are going to tell me that it's actually working? And if the system stops working, don't just run to fixing things. Make some experiments to confirm that it is failing in the way that you think it is. Make an experiment that will go from red to green as you fix the issue. And you just have to handle it in a slightly different way. So I'm going to show you something going wrong with async code by going to a code example for the account UUID and log thing that we were talking about before. So this code's using our open source Nebula core library for the trigger handlers, but you don't particularly need to know that library. You can kind of assume that before insert does a before insert. Of course, it'd help if it was displayed. There we go. So, yeah. Before the account's inserted, we're going to just do a very simple thing of follow tip 1 of showing our working. We're going to set some status fields to say that the asynchronous job for creating the log, record creation history status, and the UUID, we're going to set both of those to pending, and that means we want to run an async job for it. And then we're going to have 2 queuables, one for each of the 2 things that we want to do. Both of these are going to extend a parent class that's going to handle requeuing itself, basically. And these queuables are going to handle one account at a time, just for the purposes of demonstration. So all they do in their constructor is they pass the account IDs upwards, and all they do when they actually execute is this one sets the UUID, and then it sets the status field to complete, and it's done. Very straightforward and simple. That UUID is coming from an open source Apex package, which I have a link to at the end if you want a package for doing UUIDs. And the other half of it, where we're creating logs, is much the same. All the execute method has to do is create the log, and then show our working by setting the status to complete. All makes sense, hopefully. Not too surprising. So the interesting stuff comes in that parent class where we're handling all the queuable stuff. Interesting side note, I said asynchronous is a bit tricky. When I built this example, I originally had an iterator instead of a list there. That breaks queuables. Apex engineering are looking at why. So don't put an iterator in your queuable. So all it does in the constructor then is it takes a list of things that it's going to process, and it's going to pop IDs off of that list every time it executes. So the execute method is going to demand that the child classes have a method to process a single account. And then it's going to query the account to get some fresh data. And as it does that, it's going to remove one of the IDs from the list there. So the next thing it does is it calls the execute from the child, so that's going to create an log where it set the UUID, and then it's going to see, are there any more to process, and if they are, re-enqueue yourself. So there's that, and we can run a test on this. So again, this is using our framework, but you don't need to loads about it. You can get the gist that in that top part, we're creating 6 accounts, and then we're querying back those accounts to see that it has set valid UUIDs and the status is complete. So you run that, that passes, all good. Then you can run it in the real world, which is where things get interesting. So what I've done is I've created 6 actual accounts, and then I've queried back to see where we are, and we can see that the account numbers are set for 4 of them, and the log IDs are created for 4 of them, and there's a mix of statuses going on all over the place. So number 1, why there are only 4 is because this is running in a Scratch org, and queuables can only chain to a depth of 5 in Scratch orgs. Boo. And also, why is there a mix of statuses? And I'm not expecting you to answer that. There's a mix of statuses here because the log side and the UUID side are both querying the account, and they're both writing to the status, and they both think they've only done 1. So there's a race condition for them to write the statuses, and they've kind of messed it up there. So we need to move on to tip number 6 for wrangling asynchronous stuff. If running in parallel doesn't work, serialize it. Stop making it run in parallel. Pick the tricky bits and make them run synchronously. And this is what pretty much every language and every context does to solve these problems of parallel processing, is just stop. Make part of it serial. And there are various kind of standard ways of doing that. We could have record locks in the database. We could have mutex bits of code where we say only 1 process is allowed into there at a time. There are semaphores, there are tokens, there are all sorts. But all Salesforce really offers us at the moment is that when we do a query in SOQL, we can say we're querying for update, and that locks any other process from also querying it for update and makes it wait. And platform events are kind of a way of mutex that for each platform event type, there'll only ever be 1 trigger running on that at any one time. So that could be a useful way of doing things. And there's potential for adding more stuff to queuable that has been mentioned, safe harbor, but doesn't exist yet. So we can go back to the example that I had, and we can add for update to the query of that parent class. So every time we fetch the account, we make sure that the other one is not going to clash with it. And indeed, that works. All the account numbers are there, all the statuses are right. We're still stuck at 4 because it's a Scratch org. But one of the things you notice here is now the elapsed time there is 11 seconds. And in the original one, it was 1 second. And it's definitely a thing about asynchronous processing that if you're planning to do it for speed, and then you have to make certain parts of it serial to make sure that it's correct, you may well end up slower than you were in the first place. There are other reasons to do async, but it's not always faster. So one of the things about this is that the Apex tests passed. And I would say that if for update is the answer to your problem, Apex unit tests cannot ask the right questions. So Apex unit tests all run within 1 transaction and they roll it back. The whole thing shares a database connection. So all your queuables in an Apex test, they never run in parallel. So you'll never hit the problem with for update. So you just can't rely on them for this sort of thing. And that has consequences. One of the consequences are that you might have to change the way you deploy just because you've decided to use async. Suddenly your Apex unit tests are not enough to tell you that your system's correct, and you have to actually run it for real in a sandbox and make sure that things work. Maybe you're already there because you were doing it for a large data volume, but if you weren't, you've suddenly taken on this extra liability. I mentioned flow. I hope to come back to flow. You can add asynchronous paths to flow, and it can run stuff asynchronously. All the same considerations we talked about apply. It doesn't matter that it's flow. It's still race conditions and all of that stuff. But at the moment, you don't have the same sort of tooling to help you out. There's nothing like a transaction finalizer for flow. You can run them in the flow debugger. If you run something in an Apex unit test that is supposed to run asynchronous flow, it just doesn't run it. So wrapping up, the programmer's credo, we do this not because it's easy, because we thought it would be easy. Async sounds like a good idea, but it's harder than we thought. Sometimes it's essential to go asynchronous with stuff. Sometimes it's just really useful. But it can change our deployment process and it can change our confidence in our code. The challenges are not unique to Salesforce. You can read around other places and see how other people have solved it and see how that maps to what we have within Salesforce to help us with async. And a review of my tips. Show you're working, make your operations idempotent, do the hard bits once and wrap it up, belt and braces approach, treat it like science, serialize the critical sections, and don't use flow. Those are some links to relevant source repositories. So my implementation of sleep sort, but write your own first, don't cheat. The Apex examples I gave you are in that repo. Our open source library is there, and somebody else's UUID thing is there. Questions from anyone? I'll leave those up rather than go to the questions bit. Yes, Rob.
Can I suggest an alternative option for update and get your opinion on?
Oh yeah, it's not a clever way to solve that problem, but go on.
Yeah, basically the issue in that particular example happened because you're writing data that you don't need to write into that update.
Yeah.
You've got an overlap in those statuses because you're selecting those back before you write back, and you're writing back the whole thing.
Yep.
What would you say to the assertion that actually whenever you're writing a record, you should only be writing the things that you care about at that point? So, for example, create a new version of the account,
Yep.
only the things that you want to update and then sending that. Does that make things simpler, or does it actually make it harder because you've got more things to reason about to in that separation and understanding which things are isolated, which things aren't? What's your take on it?
I think you're 100% right that you should only write to the fields that your process actually needs to write about. I really had to make that example quite tortured to make it small enough to fit on a slide. Like I was querying the record and then cloning it purely to make it go wrong. And if you do only write to the fields that you need to write to, you do get around that problem until the day where you have two processes that really do want to write to the same place. And I just wanted to make a small example that worked like that, but I would advise only write to the fields that you want, and then you can go for longer before you get into trouble. Yeah?
It's on coaching, potentially. So I have a junior developer who's sort of approached tech through Salesforce and Apex. And I think Apex is very good at giving you the illusion that everything is single-threaded.
Yes.
So he's having real trouble understanding async processing.
Mm-hmm.
How do you take somebody junior through that journey?
Have you got an easy question? I think JavaScript might be an easier language to think about these things in because the idea of promises is a bit more kind of baked into it. Yeah. And there's lots of existing tutorials around those things, but it's just a hard step to take in your mind to understand this stuff. And I guess that was one of the difficulties that I didn't highlight, is that it may leave some of your team behind if you move into doing stuff in async processing. There may be people who just can't really touch that code because they don't understand it. Yep.
About Apex unit tests, not just test some of this stuff. Have you got like a recommended approach or framework for how you run the tests for these things in a
No. We've tended to sort of bundle it in with the UAT, test the front end type stuff. Cool, well, thank you all.
Aidan with Salesforce is a game changer, an easy-to-use financial package that provides advanced features that you simply can't get from Xero or QuickBooks. It's based on a simple truth that integrating your finance and CRM systems on Salesforce is efficient. All your data's in one place. There are no integrations. Dashboards deliver your reporting without complicated Excel spreadsheets. Native Salesforce automates the mundane. Implementation is quick in one VAT quarter, and minimal training is required. There are 3 versions: free forever, economy, and business class, which adds more sophisticated features and multi-companies. And it's all backed up with a 12-month, no argument, money-back guarantee. Thank you for listening.